Okay, so let us start the class because it has been very irritating that they are joining very late. I have given the break 5 minutes. That means it does not mean that you can take more time. Okay, so where we are solving the problem. We see that the numerical is continuated, and we see that H1m equals to 2 by 5 all to the power m, whereas H2n equals to 1 by 5 all to the power m, and H2n minus m equals to 1 by 5 all to the power n minus m. So the product H1m and H2n minus m will be non-zero when it will be non-zero in the range of 0 m lies in between n, because it has been multiplied by un. So unit step signal is what? From 0 to n it is satisfied, and after that it is 0. So anything will be multiplied by 0, it will be 0. So that will be what? It will be 0 to m. Sorry, 0 to n. Therefore, the summation index. Therefore, the summation index will be also changed. So what will be the summation index? Now the summation index will be from 0 to n. So we can write now h of n equals to summation of m equals to 0 to small m. H1m into H2n minus m. So that will be represented as summation of m equals to 0 to n 2 by 5 whole to the power m into 1 by 5 whole to the power n minus m. So that is equals to summation of m equals to 0 to n 2 by 5 whole to the power m 1 by 5 whole to the power n, and I can write 1 by 5 whole to the power minus n. So this is a limit of 0 to n, that is the value of m from 0 to n. So this is n. So there I can take it out of the summation because n is not the limit. So I can write 1 by 5 whole to the power n into summation of m equals to 0 to n 2 by 5 whole to the power m into 1 by 5 whole to the power minus n. So this can be also written as 1 by 5 whole to the power n summation of m equals to 0 to n 2 by 5 whole to the power m into 5 to the power m. We can write this.
Yes, sir.
Next, continuation from there. If it is 1 by 5 whole to the power n, so if this is 2 or m, so I can multiply. So summation of m equals to 0 to n, and then if I multiply it, what will get? 2 into 5 by 5 whole to the power m. So that becomes 1 by 5 whole to the power n summation of m equals to 0 to n, and then this becomes what? Yes, 2 to the power m. Now finite geometrical formula, what is that? Finite GM series, geometric series. Some formula, what is that? Anybody knows that? It is said summation of n equals to 0 to capital N, c to the power n equals to c of n plus 1 minus of 1 by c minus 1. So this is the formula. We must learn by heart. So with the help of this formula, what I can write? 1 by 5 whole to the power n into 2 to the power n plus 1 minus 1 by 2 minus 1. Here is capital N, so it is the limit is small n. So I write here. So that is equals to 1 by 5 whole to the power n into 2 to the power n plus 1 minus 1. When? For n greater than equals to 0. So that can be also written as 1 by 5 whole to the power n 2 to the power n plus 1 minus 1 u to the power n for all values of all of n. So this is the answer. So anybody, any problem, please you can tell.
No, sir.
So nobody, no problem, I think. So this type of problem will come into the examination on interconnection of discrete time system. So please practice like these problems. Another type for interconnection of discrete time system will come. Let us give another type. There is 18/1/2022. So we are talking about numericals. And this is number 2. Determine the overall response of the interconnected discrete time systems shown below. So let us do these interconnections. Let us draw the figure. This is our xn. This is h1n. This is what? h2n. This is another impulse. Sorry, this is h3n. This is h2n. And this is another impulse, h4n. Now there is an adder. That gives you the output y of n. So it is given that h1n equals to a to the power n un, h2n equals to delta n minus 1, and h3n equals to delta n minus 2. And just a wrong thing I have written. This is not h4n, this is h1n. So this is given to us and we have to solve this problem. So you can see here, there are two types of connection used here. One is cascade, another is parallel. So 2 times of this is merged in this signal. So how to do it? कैसे करेंगे?
ये सीरीज में दोनों को कर लेंगे सर, उसके बाद फिर पैरेलल में करना।
हाँ, पहले कैस्केड कर लेंगे। कैस्केड कर लेने से अगर इसको रीड्रॉ करें तो द इक्विवेलेंट system is shown below. तो एक इक्विवेलेंट सिस्टम ड्रॉ कर लेते हैं। ये एक्शन है हमारा, तो इन दोनों कैस्केड में है, तो इसका इक्विवेलेंट होगा क्या? कन्वोल्यूशन होगा। तो हम लोग कन्वोल्यूशन कर लेते हैं। So H1n is convoluted with H2n. अब इसके साथ ये ऐड हो जाएगा। नीचे वाला कौन होगा? H3n is convoluted with H1n. अब इसका जो इक्विवेलेंट सर्किट होगा, अगर हम लोग ड्रॉ करेंगे तो क्या होगा? x of n this will be H1n convoluted with H2n that is added with H3n convoluted with H1n. That gives you y of n. So that is also simplified as x of n this is represented as h of n, it is given as y of n. So this is the equivalent circuit diagram of this connection or equivalent system, not circuit diagram, equivalent system. Now the solution means numerical calculation. So first what we have to do, we have to do the convolution of H1n and H2n. So we can write here So here h of n equals to, I can take h1n convoluted with h2n plus h3n convoluted with h1n. That is the check. So first, evaluating the convolution of h1n and h2n. So h1n is convoluted with h2n. That gives you summation of m equals to minus infinity to plus infinity h1m into h2n minus m. That is equals to summation of m equals to minus infinity to plus infinity h2m into h1n minus m. It is using the commutative property, using commutative property. Why I do this? Because h2 is delta n minus 1 and h1n equals to a to the power un. So it is very easy to delay the a to the power n un, a to the power n un than delta n minus 1. So that's why I changed it from h2 to h1 using the commutative property. So these things, these all the tricks you have to be in mind, or there is no hard and fast rule that you have to do it like this. You have to do the solution, and how you will do the solution, you know the distributive, associative, commutative property, and you have to solve it for your easiness. Like the algebra, what you have done in algebra solutions. Here also this solution you have to do. So that is a summation of m equals to minus infinity to plus infinity delta m minus 1 to a to the power n minus m. So that is equals to summation of m equals to minus infinity to plus infinity delta m minus 1 into a to the power n a to the power minus m. Now I will take out a to the power n outside. Then I give the summation of m equals to minus infinity to plus infinity delta m minus 1 to a to the power minus of m. So the product of delta m minus 1 and a to the power minus m in the above equation will be non-zero when m equals to 1 will be non-zero when m equals to 1. So by this we will get h1n convolution with h to n is equal to a to the power n the minus 1, that is equals to a to the power n minus 1 when for n greater than equals to 0 and equals to a to the power n minus 1 u of n minus 1 for all values of n. Okay. Now okay, so no problem. Now let us evaluate the convolution of H3n and H1n. H3n and H1n. So convolution of H3n with H21n, that is equals to summation of n equals to minus infinity to plus infinity H3n into H1n minus m, that is equals to summation of m equals to minus infinity to plus infinity delta m minus 2 into a to the power n minus m, that is equals to summation m equals to minus infinity to plus infinity delta m minus 2 into a to the power n a to the power minus m. And again, a to the power n is kept outside, summation n equals to, so m equals to minus infinity to plus infinity delta m minus 2 into a to the power minus m. So the product of delta m minus 2 and a to the power minus m in the above equation in the above equation will be non-zero When?
m बराबर 2.
Yes. Only when m equals to 2. So that is h1n equals to sorry. H3n convolution with H1n equals to a to the power n into a to the power minus 2. That is equals to a to the power n minus 2. When for n greater than equals to 2. And a to the power n minus 2 u of n minus 2 when for all of n. So now the overall impulse response Hn is given by h of n equals to h1n convolution with h to n plus of h3n convolution with h1n. So that is equals to a to the power n minus 1 u of n minus 1 plus a to the power n minus 2 into u of n minus 2. That is our answer. So up to this, anybody, any problem?
No, sir.
So is it clear to everybody?
Yes, sir.
So this is the numerical problem that we are discussing about. Hope everybody has understand this problem. And this is the assignment 2, number 3. I have given the assignment 2 today. Assignment 2. So in that assignment 2, first question is to prove that I'm just reciting. You have written the question previously, that overall impulse response of two cascade discrete time system is given by the convolution of individual impulse response. That means Xn is gettable the cascade H1n into H2n, and we get the output Y of n. So this is the first for cascade. You have to prove. Next is our assignment that for a parallel, Xn will be what? It will be plus So sum of the overall impulse response of two parallel connected discrete time systems is given by sum of individual impulse response, that is h1n plus h2n, that is of y of n for parallel. And number 3 will be, so 3 questions are there, 30 total marks will be there. Last was also 30. So determine the overall impulse response of the interconnected discrete time system as shown below. So xn is this. We have 2. One is h1n. One is h2n. There is an adder. Here is another signal. This is H3n. Now this will be added. You get it here one, you get it here one. This is y of n. So please give your the attendance. Less than a minute is there. Everybody, quickly. H1n equals to 1/3 to the power n un. H2n equals to 1 to the power. Just one student has given 2. H3n equals to 1/5 to the power n un. So if you don't give your